something strange happened the night 3I/Atlas crossed into China's deep space tracking range. And then, silence. Within hours, major observatories in the region went dark. Data feeds stopped updating, and official statements vanished. Days later, Dr. Michio Kaku made a chilling observation. Silence in science is never accidental. If Beijing's telescopes saw what NASA couldn't, the implications could shake every assumption we have about interstellar objects. Kaku suggests they didn't lose the signal. They found something they weren't ready to explain, something powerful enough to demand secrecy on a global scale. Because if China really detected what 3I/Atlas is, then the world's biggest mystery may no longer belong to space, but to whoever saw it first. November 5th, 2025. The National Astronomical Observatories of China operate a network of facilities stretching from the Tibetan Plateau to the remote deserts of Xinjiang. Among them, the 500-meter aperture spherical telescope, known as FAST, holds the distinction of being the world's largest single-dish radio telescope. On paper, FAST is dedicated to pulsar research and the search for extraterrestrial intelligence. In practice, it observes anything of interest passing through accessible coordinates. On the evening of November 5th, 3I/Atlas entered FAST's observation window. The comet was positioned optimally, high above the horizon with minimal atmospheric interference. Observation time had been allocated weeks in advance, coordinated through the Chinese Academy of Sciences. The scheduled observation began at 1842 Beijing time. FAST's receivers, capable of detecting signals across frequencies from 70 MHz to 3 GHz, locked onto 3I/Atlas position. Initial data confirmed the target's presence. Radio emission at expected levels for a comet producing ionized gas as it interacted with the solar wind. The observation plan called for 6 hours of continuous monitoring, tracking 3I/Atlas as it moved slowly across the sky. 3 hours into the session, at 21:47 Beijing time, something changed. FAST's data stream, normally accessible through internal networks to authorized researchers across China's astronomical community, went offline. Not a gradual degradation, an abrupt cutoff. Dr. Wei Chen, a radio astronomer at Nanjing University who had been remotely monitoring the observation, noticed the disconnection immediately. He attempted to reconnect. Access denied. He contacted colleagues at other institutions who were also tracking the observation. They reported the same problem. The FAST data feed had been terminated. Wei assumed technical failure, perhaps a network issue at the telescope site. Such problems, while rare, did occur. What made him uneasy was the timing. The cutoff had happened mid-observation, during a period when FAST's systems were functioning perfectly. And it wasn't just FAST. Within 90 minutes, 3 other Chinese observatories with active observations of 3I/Atlas, including facilities in Yunnan and Inner Mongolia, stopped publishing data updates. By November 6th, the silence had become conspicuous. FAST's official website, which routinely posted observation schedules and preliminary results, showed no mention of the 3I/Atlas observation. Queries sent to the National Astronomical Observatories received automated responses, citing routine maintenance and data verification procedures. Dr. Wei attempted to reach colleagues directly involved in the FAST observation. Calls went unanswered. Emails received brief, formal replies stating that results would be released pending review. No timeline, no details, just assurances that everything was proceeding normally. International observers began noticing the data gap. Dr. Bill Gray, tracking 3I/Atlas observations worldwide, noted that Chinese facilities, which had been regularly contributing position measurements and photometry to shared databases, had stopped submitting data on November 6th. He posted a query to the Minor Planet mailing list asking if anyone had recent observations from Chinese telescopes. No response from Chinese institutions. Other observers confirmed the pattern. China's astronomical community, normally active in international collaboration, had gone silent on 3I/Atlas. On November 9th, Dr. Michio Kaku, theoretical physicist and science communicator, made a public statement during a radio interview. Kaku had been following the 3I/Atlas story with interest, commenting on its unusual properties in several media appearances. When asked about the Chinese observation blackout, his response was measured but pointed. In science, silence is never accidental. When major observatories go dark simultaneously on a specific target, it's not technical failure, it's a decision. And decisions like that are made when something significant has been detected, something that requires careful analysis before public disclosure, or something that raises questions no one is ready to answer. The interview clip spread rapidly across social media and scientific forums. Kaku's implication was clear. China had observed something about 3I/Atlas that prompted institutional suppression. Whether that meant discovery of unusual properties, detection of artificial signals, or observation of behavior that couldn't be explained by natural processes, the silence itself was evidence that the routine observation produced non-routine results. Within 24 hours, Kaku expanded on his statement through social media, posting, "In scientific collaboration, transparency thrives. When a major player suddenly stops sharing data on an object of global interest, we must ask what they saw that changed the equation. Silence, in this context, is confirmation that something was found." NASA's response to the Chinese blackout was diplomatically neutral. When pressed by reporters about whether the agency had experienced similar observation anomalies, a spokesperson stated that observational challenges with 3I/Atlas are well documented and relate to the object's variable brightness and electromagnetic properties. No mention of China, no acknowledgement that a coordinated data suppression might be underway. The European Space Agency issued no statement at all. Privately, researchers at both agencies were asking the same questions everyone else was. What had FAST detected? And why had Beijing chosen silence over science? On November 11th, a curious detail emerged. NASA's Deep Space Network, which maintains continuous observation logs for tracking spacecraft and monitoring solar system objects, showed a scheduled maintenance window for its Goldstone facility on November 5th and 6th. The maintenance had been announced weeks in advance, routine work on antenna systems, but the timing raised eyebrows. Goldstone would have been optimally positioned to observe 3I/Atlas during the same window when Chinese telescopes went dark. Coincidence, perhaps, but coincidences were becoming harder to accept. Dr. Helena Marsh at ESA attempted to contact colleagues at the National Astronomical Observatories through official channels. Her inquiry, sent via the International Astronomical Union's protocols for data sharing, asked specifically whether Chinese facilities had obtained spectroscopic or high-resolution imaging data during the November 5th observation window. The response, when it arrived 3 days later, was brief. Observational data from recent sessions is currently under internal review. Results will be shared through appropriate channels following standard validation procedures. The phrasing was correct, professional, and utterly uninformative. Unofficial channels told a different story. Dr. Linda Vasquez, through a contact at a European university who collaborated with Chinese researchers, learned that researchers directly involved in the fast observation had been instructed to halt all external communications about 3I/Atlas pending completion of an internal review. The directive had come from administrative levels above the observatory itself, suggesting institutional or governmental involvement. Researchers were reportedly frustrated, caught between scientific norms of open sharing and institutional mandates for secrecy.
November 14th, a preprint paper appeared briefly on Archive, the online repository for scientific manuscripts awaiting peer review. The paper, titled Anomalous Spectral Features in Radio Observations of Interstellar Object 3I/Atlas, listed 5 authors, all affiliated with institutions in China. The abstract described detection of non-thermal emission patterns inconsistent with known cometary plasma processes during observations conducted between November 5th and 6th. The paper included preliminary data showing radio signals at frequencies between 1.2 and 1.8 gigahertz that exhibited what the authors called coherent modulation, with a repetition period of 4.7 seconds. Within 6 hours of posting, the paper was removed. The authors' names disappeared from Archive's database. Attempts to access cached versions failed. The paper had been scrubbed. Dr. Marco Langbroek, who monitors Archive daily for astronomy preprints, had downloaded the paper during the brief window it was available. He shared the PDF with a small circle of colleagues, including Dr. Marcus Chen and Dr. Bill Gray. The data was extraordinary. FAST's receivers had detected radio emission from 3I/Atlas that wasn't continuous background noise. It pulsed. The modulation wasn't subtle. Signal strength varied by factors of 3 to 5 over the 4.7-second cycle, far beyond what random fluctuations could produce. More striking was the frequency stability. The emission remained locked to specific frequencies with precision of less than 1 Hz drift over hours of observation. Natural radio sources, from pulsars to planetary magnetospheres, show frequency variations due to motion, rotation, and environmental changes. This signal was stable. The paper's discussion section, written with careful scientific language, noted that while natural mechanisms for such coherent emission cannot be entirely excluded, the observed characteristics more closely resemble artificial signal generation than known astrophysical processes. That single sentence, buried in technical prose, was enough to explain why the paper had been pulled. The authors were suggesting, however cautiously, that 3I/Atlas was transmitting, not randomly emitting, transmitting, with structure, stability, and repetition that implied intent. Chen forwarded the paper to Dr. Michio Kaku. Kaku's response came within hours, posted publicly. The disappeared paper from Chinese researchers described exactly what SETI has been searching for: a coherent modulated signal from an object not originating in our solar system. If these observations are verified, we're not looking at a rock anymore. We're looking at a structure, and someone decided the world wasn't ready to know that. On November 16th, the scientific community noticed another anomaly. 3 Chinese astrophysicists who had been active participants in international forums discussing 3I/Atlas suddenly withdrew from all platforms. Dr. Louis Sin Wei, a spectroscopist who had published extensively on cometary composition, stopped responding to emails. Dr. Zhang Min, a radio astronomer known for collaborative projects with European institutions, disappeared from academic conferences where he had been scheduled to present. Dr. Huang Lei, who had been vocal on social media about 3I/Atlas's unusual properties, deleted his accounts. Colleagues who knew them personally reported receiving brief messages citing increased institutional commitments or focus on domestic projects. The timing was unmistakable. These were researchers with expertise directly relevant to interpreting FAST's observations, and they had been silenced. Dr. Yuki Takahashi in Japan received an unusual communication on November 17th. An encrypted email from an address he didn't recognize contained a single attachment, a data file labeled FAST 3i/Atlas nav5.spectral. No message, no explanation. Takahashi was cautious. Unsolicited data from anonymous sources could be anything from hoax to malware. But curiosity won. He opened the file in an isolated system. It contained spectral data, frequencies versus intensity measurements, time-stamped to match the November 5th FAST observation window. The data showed exactly what the disappeared preprint had described: coherent modulation at 4.7-second intervals, frequencies locked with unnatural precision, and something the paper hadn't mentioned: harmonic structure. The primary signal at 1.42 GHz was accompanied by weaker emissions at exact integer multiples of that frequency: 2.84 GHz, 4.26 GHz. Harmonics are common in artificial transmitters, where electronic circuits naturally generate multiples of the base frequency. They're extremely rare in natural astrophysical sources. Takahashi contacted Dr. Chen. Together, they analyzed the data. Chen ran the signal through pattern recognition algorithms designed to detect non-random structures. The results were unambiguous. The modulation contained periodicities at multiple timescales: the 4.7-second primary cycle, a 94-second secondary modulation, and hints of even longer patterns embedded in the data. This wasn't noise. It wasn't random plasma turbulence. It was layered, structured, and far too organized to be natural. Chen prepared a technical report summarizing the findings. Before publishing, he contacted colleagues at NASA and ESA, sharing the data and analysis. The response was muted: acknowledgement of receipt, thanks for sharing. No commitments to follow up or verify. NASA's internal discussions, which leaked through unofficial channels days later, revealed sharp divisions. One faction argued that the data, if authentic, required immediate investigation and public disclosure. Another faction, concerned about credibility and the potential for mass panic, advocated caution. Verification would take time. The source of the leaked data was unknown. Publishing preliminary findings based on possibly compromised information could damage NASA's reputation if the data proved fraudulent. The agency chose silence, neither confirming nor denying the significance of China's observations. On November 19th, Dr. Michio Kaku appeared on a major news network and made his most direct statement yet. When multiple independent lines of evidence point to the same conclusion, scientific integrity demands we face that conclusion, however uncomfortable. 3i/Atlas exhibits controlled trajectory changes. It generates electromagnetic effects that disrupt observation. And now we have reports from credible sources within China's scientific community of coherent radio signals with characteristics inconsistent with known natural emission. This is not a comet. This is a structure, possibly a probe, possibly even something more complex. And the fact that governments are choosing secrecy over disclosure tells us they've reached the same conclusion but lack the courage to say it publicly. The segment went viral. Within 24 hours, it had been viewed more than 15 million times. Public reaction split predictably. Some dismissed Kaku's claims as sensationalism. Others saw confirmation of long-held beliefs about extraterrestrial visitation. The scientific community remained cautiously skeptical, noting that extraordinary claims required extraordinary evidence and that leaked data of uncertain provenance didn't meet that standard. But privately, conversations were shifting. The accumulation of anomalies, observational failures, data suppression, trajectory deviations, electromagnetic interference, and now reports of structured radio signals was becoming impossible to explain through conventional frameworks. Dr. Linda Vasquez compiled a timeline of events surrounding China's observation blackout. November 5th, FAST observes 3I/Atlas. Data feed cuts mid-session. November 6th, multiple Chinese observatories stop publishing 3I/Atlas data. November 9th, Michio Kaku publicly questions the silence. November 14th, a preprint describing coherent radio signals appears and vanishes. November 16th, Chinese researchers withdraw from international collaborations. November 17th, anonymous leak of fast spectral data. The progression suggested a coordinated response to an unexpected discovery. Something observed during those initial hours had triggered institutional protocols designed to contain information rather than share it, and those protocols were still in effect. The question haunting everyone who studied the timeline was simple. If the observation had been routine, showing only expected cometary behavior, why the extreme response? Technical data from comet observations is shared freely, published in journals, discussed openly. Suppression only makes sense if the data reveals something that challenges fundamental assumptions or carries implications beyond pure science. And 3I/Atlas, with every passing week, was demonstrating that it challenged every assumption observers brought to it.
November 22nd. The term quantum brightness phenomenon appeared in a leaked internal memo from the Chinese Academy of Sciences. The memo, circulated among Dr. Vasquez's network of contacts, described measurements obtained during the November 5th observation that defied conventional physics. According to the document, FAST had detected luminosity variations in 3I/Atlas that occurred faster than light travel time across the object's estimated size. If the comet's nucleus was approximately 180 meters in diameter, light takes roughly 600 nanoseconds to cross that distance. The brightness changes FAST recorded were synchronized across the entire visible surface to within 50 nanoseconds. For the whole object to brighten and dim in perfect unison that quickly, information about the brightness change would need to propagate faster than light, or the entire structure would need to be responding to a single coordinated signal. Dr. Chen read the memo 3 times. Quantum entanglement allowed instantaneous correlation between particles, but macroscopic objects don't exhibit quantum coherence at room temperature, let alone at the scale of a 180-meter nucleus heated by the sun. Either FAST's timing systems had malfunctioned, producing spurious measurements, or 3I/Atlas was demonstrating physics that shouldn't be possible. The memo's author, whose name had been redacted, noted that observed synchronization exceeds classical limits and may indicate non-local coordination mechanism, or engineered response system. Translation: this object was either breaking the laws of physics or using technology that controlled its entire surface simultaneously. On November 24th, tensions between space agencies reached a breaking point. The European Space Agency's Director General, in a rare public statement, called for full transparency and international cooperation in observations of interstellar object 3I/Atlas. The statement, diplomatically worded, was clearly directed at both China and NASA. It acknowledged that multiple facilities have obtained data of significant scientific interest and urged immediate sharing through established international protocols. The statement stopped short of accusing anyone of deliberate suppression, but the implication was clear. ESA knew that critical data was being withheld and was publicly pressuring the other major players to release it. NASA responded within hours. A terse press release stated that all observational data obtained by NASA facilities is processed through standard validation procedures before public release, and that collaboration with international partners continues through appropriate channels. The statement mentioned nothing about China, nothing about the FAST observations, nothing about the coherent radio signals. It was a masterclass in saying nothing while appearing to respond. China's space agency issued no statement at all. Behind the scenes, the information war intensified.
Dr. Takahashi learned from contacts in Beijing that the original fast observation team had been reassigned to other projects. The lead investigator, Dr. Liu Xinwei, was reportedly no longer at his institution, though where he had gone remained unclear. Rumors circulated that the Chinese government had classified the entire November 5th observation under national security protocols, effectively silencing anyone with direct knowledge. If true, it meant China had decided that whatever fast detected carried implications beyond science, touching on defense, intelligence, or strategic interests. Dr. Michio Kaku made his final and most provocative statement on November 26th during a live-streamed discussion with colleagues. "We need to face what the evidence is telling us," Kaku said, his tone uncharacteristically grave. "This is not a rock. Rocks don't generate planetary strength magnetic fields. Rocks don't execute precision trajectory corrections. Rocks don't emit coherent radio signals with harmonic structure. Rocks don't synchronize brightness changes faster than light should allow. Every single observation that succeeds in capturing clear data shows characteristics inconsistent with natural objects. And every time someone gets close to definitive proof, the data disappears or the observer goes silent." China's telescopes saw something on November 5th that made them shut down their entire observation program and classify the results. That's not caution, that's confirmation. They know what 3i Atlas is, and they've decided the world isn't ready to hear it. The response was immediate and divided. Mainstream scientific institutions distanced themselves from Kaku's claims, emphasizing the need for peer-reviewed verification and warning against premature conclusions. But the public conversation had shifted. Polls showed that more than 60% of respondents believed 3i Atlas was something other than a natural comet, though what that something might be ranged from alien probe to secret military experiment. The object had transcended astronomy, becoming a cultural phenomenon that touched on fundamental questions about humanity's place in the universe and the trustworthiness of institutions charged with investigating the unknown. On November 28th, a breakthrough came from an unexpected source. Dr. Paolo Candy, the Italian amateur astronomer who had been documenting 3i Atlas's visibility fluctuations, obtained spectroscopic data during a rare clear observation window. His equipment, a modest 40-centimeter telescope with a low-resolution spectrograph, wasn't capable of the precision fast or major observations could achieve. But it captured something they had missed or chosen not to share. A faint emission line at 589.3 nanometers. Sodium. Comets do emit sodium, released when solar radiation breaks down minerals in the nucleus. But the intensity and narrowness of Candy's detected line suggested something different. The emission was too strong for passive release and too spectrally pure for thermal processes. It looked like stimulated emission, sodium atoms excited by a coherent light source, essentially a sodium laser. Candy posted his spectrum online with minimal commentary, simply noting the unusual characteristics and inviting others to verify. Within 48 hours, 3 other amateur observers in different hemispheres confirmed the detection. All captured the same sodium line during brief windows when 3i Atlas was visible. The professional community couldn't ignore amateur data replicated across multiple independent observers. Dr. Carrie Liss at Johns Hopkins, who had been studying 3i Atlas's spectroscopy since August, obtained higher resolution spectra using a professional facility. Her data confirmed Candy's finding. The sodium emission was real, abnormally intense, and exhibited characteristics consistent with stimulated rather than spontaneous emission. Stimulated emission requires population inversion, a condition where atoms are artificially pumped into excited states by external energy. Nature produces this in some extreme environments, certain types of masers in interstellar clouds or around dying stars, but not in comets, and not with the spectral purity observed in 3i Atlas. Liss's analysis suggested that if this was stimulated emission, the pumping mechanism was delivering energy with remarkable efficiency, targeting specific atomic transitions with precision that implied either extraordinarily fortuitous natural conditions or deliberate engineering. Dr. Chen compiled every piece of evidence into a comprehensive document. Trajectory deviations inconsistent with natural acceleration, electromagnetic interference affecting observation equipment, adaptive dimming synchronized globally, coherent radio signals with harmonic structure, quantum-scale brightness synchronization, stimulated sodium emission. Each anomaly individually could potentially be explained, though explanations required increasingly exotic natural mechanisms. Collectively, the probability that all anomalies resulted from natural processes had become vanishingly small. Dr. Chen's conclusion, stated carefully but unambiguously, the balance of evidence suggests 3I Atlas is not a natural object. Imperative investigation is essential. He submitted the document to the International Astronomical Union on November 30th, formally requesting that an emergency working group be convened to coordinate global observations and data sharing. The request was acknowledged, but not immediately acted upon. Bureaucratic processes move slowly, especially when faced with conclusions that challenge fundamental assumptions. Meanwhile, 3I Atlas continued its precisely calculated path through the solar system, now just 8 days from its predicted passage through the Earth's magnetotail. Whatever it was, wherever it came from, and whoever saw the truth first, the object was entering its most critical phase, and the silence from those who knew the most had become, as Michio Kaku predicted, the loudest confirmation of all.